Welcome. In this video, I'm going to talk to you about how many solutions a system of linear equation has based on the rank of a matrix coefficient. So let's look at what we're going to look. Okay, so how many solutions of a system of linear equations. So first we're going to look at two things. We're going to look at the rank of A, and we're going to look at something called the dot product. So the rank of A, where A is the coefficient matrix. So notice, I'm gonna call, so let's say you have a system that looks something like this. X1, you have A plus x1 plus x2, so xn, no, xm, no, I'm sorry, x comma x2, and then all the way to xm, and then you have you can say this is B, this is A1, A2, BM. Let's say you have AN of x1, so this one will be A11, A21, this will be A12, and this will be A1M. This will be A1N. This will be A2N, X2, all the way to B. All the way to, this is A, and this will be A M N. So this will be, and then this is equal to x1 all the way to xn. So this is what your system looks like, system of linear equations. So what we're gonna do, we're gonna concentrate only on the coefficients. What that means is that instead of looking at the whole thing, we're only gonna look at the coefficients of the system of linear equations. So that's gonna be something that looks like this: A1n, A1n, so it'll be A M1, so we can call this one A1. A11, this will be M1. This will be, we can call this one AN1, or this, let's okay, so basically okay, let's do Aij where I is equal to the row and J is equal to the column. In this case, we're using N and M, so AI will be your, so I will be your N, and J will be your M. And this would be the same thing as I is N, N, M. So that will, so this will be your NM column. Any. This represents any entry on the coefficient matrix. Okay, so we have N, the first row is 1, first column is 1. So first row will be 1, and the second column and the M column will be the second here, so 1M. So here we would have first row will be N, and the second and it will be 1 because that will be a first column, and then we will have A, N, M, which is the last one. Okay, so now we know that A represents this here. So what can we say about that coefficient matrix? What we can say are, I'm gonna concentrate on 3 things. We're talking about how many solutions. Before we talk about something called RREF, reduce row echelon form of a matrix. But remember, when we did that, we included your x vector and your coefficient, which is your Aij, what we were talking about. So here we're only gonna concentrate the REF. We're gonna only concentrate here. So to find the rank of A, we need to transform a matrix into a row reduced echelon form. So once it is in that form, we can say 3 things. The first thing, it says that we have a single solution, or just one solution when rank of A is equal to N, which is, remember, what did I say? N represents the number of rows. Okay. Moreover, because the matrix is in row reduced echelon form, that means that we have n rows with leading ones, because it's in row reduced echelon form. So for example, we have something like this: A0, 1, 0. How many leading ones? We have 1, 2. And this matrix is in row reduced, is in RREF. That means that how many rows we have? 1, 2, 1, 2. That means that the rank of A, if this is your A, will be 2. And that means that n, for one solution, it will always have n leading ones. Number 2, if rank of A is less than M okay, M represents a number of columns. With ones on it. So if it has one, because it's in row reduce, ones, and remember in a row reduce, for example, something that looks like this, let me show you, 1 0 0 0. For example, here we have this one is called a free variable. We're gonna have one free variable. The problem with this one is that here, because we have a free variable, we're gonna, the rank, remember how many ones, how many columns, ones in each column, we have one, only one. That means that rank of A is equal to 1, which is less than M, which is equal to how many columns we have? 1, 2. So which is less than 2. And we have, and the ones that are remaining here are zeros. That means here we have infinitely many solutions. The third case, when we have no solutions. There's only one case where we will have no solutions. If you have a matrix that looks like this, when you, after you do row reduce echelon form, that looks something like this. For example, it looks and then in this case, for the no solution, we need to look at the, let's say this is 2, this is 3, and let's say this is 1. In this case, you're gonna have 0 equal to 1 here. This is the augmented matrix. So we'll look at this one. The only case where you're gonna have no solution is when you have something that looks like this. You have all zeros and then you have a 1 for your x vector. So this basically looks something like ax equals b. So when this here has a 1 and they're all zeros, that means that you're gonna have no solution. As soon as you spot that, you're gonna have no solution. So those are the 3 cases when you're looking at the rank of the matrix. Of course, that when you're looking at no solution, then that's the only case where you look at here. But let's say you have 0, 0, you have the free variable, then in this case you have infinitely, like I said, infinitely solutions. Okay. So I'm gonna leave you with two things. I'm gonna give you one example. We're gonna find the rank of the matrix. So let's say A is equal to 1, 0, 0, 1. And let's say, just to, so in case you have no solution, we're gonna look at I'm gonna include your matrix. Okay. So in this case, the system looks as follows. X1, let's say this is X1. X1 is equal to 2, and X2 here is equal to 3. As you can see, we don't have free variables, so this system has one solution, and here is your solution. Now, what can I say about the rank of A? Well, this one is already in RREF. How many leaders ones? We have one here, one here. That means that rank of A is equal to 2. So two things, rank and one solution. And you can similar say for the other ones. When you have a free variable, you're gonna have infinitely many solutions, and rank is less than the leading ones. I'm sorry, less than the number of columns. And also, if you see something like 0, 0, 1, immediately no solution. But this is not the case here. Okay. So let's look at, okay, A is equal to 1, 0, 0, 0, and then we're gonna say 1, and this is 3. So rank of A is equal to 1. How many columns? 1, 2 is less than M, which is equal to 2. And what this says is that we have no solution. And the reason is because we see this pattern here. And of course the last one. Okay, let's say A is equal to 1, 0, and then we have 0, 0, and then 0, and this is 3. That means the rank of A is equal to 1. We is less than m, because we have 2 columns, which is equal to 2, but we have what? A free variable. So this tells us that we have infinitely many solutions. In a previous video I taught you what happens when you have infinitely many solutions, how to write it. So for example, in this case you're gonna have, let's say this is x1 and this is x2. You can say that x1 and x2 is equal to x1 is equal to 3, and then x2 is equal to t, a variable, and then this tells us we have infinitely many solutions. Thank you very much. That's all I wanted to teach you in this video. Please don't forget to subscribe.